All right, ladies and gentlemen, welcome to 14.1 here. We're talking a little bit about heating curves and seeing what's going on in terms of the motion of the molecules. Really, there are two things that we need to be familiar with when we talk about how the molecules are behaving. And really, I want to know about the speed, and I want to know about the spacing. So anytime we start talking about the speed or spacing, then we're talking about how molecules actually are behaving. All right, ladies and gentlemen, again, I apologize coming back to you. Again, we're talking about the molecules of the atoms inside of these substances as they move from point A to point B to point C, etc. From there. We want to take into account the speed and the spacing of the atoms. So if we take a look here at point A is at the lowest point. It's probably where the particles are going to be moving the slowest, and they're going to be the tightest together. Their spacing is going to be the most compact. So point A is really where we're going to most likely have our solid form of that substance. As it continues to move up, if you notice, point B, the temperature is increasing. If the temperature increases, that means the speed of those molecules are going to increase as well. They're going to vibrate much, much, much faster. So as those things are vibrating much, much faster, they're moving quickly, we are getting to higher temperatures. Speed is also related to our kinetic energy. Kinetic energy is going to be how fast an object is able to move. So down here with the solid, we have low kinetic energy. As we move up here, we go from a solid to a liquid. We have medium kinetic energy. And then obviously if we've gone from a solid to a liquid, we're going to be up here in the form of a gas, and this is where we're going to have high kinetic energy. Again, as the temperature increases, these molecules are vibrating faster and faster and faster, or moving faster and faster and faster from there. So as you take a look here, we go from solid to liquid to gas. The kinetic energy is changing or increasing. As we start to take a look here at D and E, what you will notice is D and E, we no longer have temperature increasing. So if the temperature is not increasing, we must be talking about the space between those particles increasing. Thank you, sir. So if we're talking about spacing, we're no longer with kinetic energy. We are now all talking about potential energy. Potential energy is the energy of position. How are those particles positioned there? So if we're talking about going from a solid to a liquid, we know those molecules are starting to spread out a little bit. In a liquid, they are still compact together, but they have enough energy to actually slide past one another. As we go from a liquid to a gas, this is where the particles are going to spread further and further out. And that's because they have so much energy, they're able to overcome that attraction force and really get far away from each other. So again, just take a look at 14.1. 14.1 is all about a heating curve, understanding what's going on, locating the parts. We have A, B, and C. A, B, and C are showing us the phases of the matter, solids, liquids, and gases. We know that because the energy line or the temperature line is increasing. So that's where we are in a liquid or solid or gas state. Again, kinetic energy, speed, faster. Faster equals higher temperatures. If we're taking a look here at D and E, temperature is not increasing, so the speed is not increasing. If the speed is not increasing, the space must be increasing, which is potential energy. Again, potential energy, we're spreading out a little bit to spreading out really far away. As you take a look at 14.1, and really that's what 14.1 is all about. How do we actually have molecules behaving? Are they moving faster, or are they moving slower? Are they spacing further apart, or are they spacing closer together? Again, taking a look, you should be able to read this. You should be able to tell me where is kinetic energy increasing, where is potential energy increasing, what do we know about the phases, what do we know about the actual states of matter. Another little side point, if we're talking about going from solid to liquid, we're talking about the melting point. If we're talking about going from a liquid to a gas, we're talking about evaporation or boiling point. Alright, so hopefully that helps clarify a little bit about what's going on with 14.1. If you got any questions, always come in and talk to me and we'll figure out what's going on.